Hey Bobcats, this is Mr. Peterson. Today we're going to look at the second part of this video, which is transforming logarithmic functions. We're just going to look at some very basic patterns that will happen in those kinds of transformations. You're going to see that they're very similar to yesterday's video with transforming exponentials. There's a lot of similar patterns there. So let's just, like we did yesterday, let's start with our parent function. You can see it right here, the log of x, of course with the base 10. So let's try log of x, but let's add 2 out behind it. And you can see the red one is our new one, our translated function. It moved 2 vertically. To do a shift downward of 2, we want to take away 2, and then you can see our red line here, or our red function. That's our new function. It has shifted down 2. So to sum that up, if you want to do a vertical translation, you need to add or subtract back behind the function. All right. Well, what if we want to do a vertical? What if we want to do a vertical? What if we want to do a horizontal translation? What if we want to do a horizontal translation? Well, we're going to add into the of part of our function. In other words, it's whatever the of. So if we add, let's say 2 into this, it's going to shift 2 to the left. Whereas if we come up here and take away 2, it's going to shift 2 to the right. So again here, kind of take away, if you want to do a horizontal translation, you need to change the numbers that are in the of. You either need to add if you want to shift to the left, and take away if we want to shift to the right. And again, that's our, just to use some of the variable language here, this is our h, whereas the vertical one would be the k. All right, well, what if we want to do a vertical stretch or compression? Well, let's go back to our parent function, what we're going to do here is we're going to multiply. We're going to multiply log base 10 of x by 2. And you can see that when we multiply, that wound up doing a vertical stretch by a factor of 2. Whereas if we instead multiply by 1/2, if we multiply by 1/2, and again, you guys know me, I like the fraction notation. 1/2 times the log of x, that did a vertical compression. A vertical compression. It got pressed down vertically. All right, well, so again, kind of key takeaway here, if you want to do a vertical stretch, you need to multiply the whole logarithm by a number greater than 1. And if you want to do a vertical compression, you need to multiply the logarithm by a number between 0 and 1. All right, well, what about a horizontal stretch or compression? Well, what we would do then is we would come up here in the of part, and if we want to do a horizontal stretch, we of course need to do the inverse of what we would think. We need to multiply in here by a fraction, and when we do that, you can see that we wound up with a horizontal stretch. It got pulled out horizontally by a factor of 2. And if we want to do a horizontal compression by a factor of 1/2, we would need to multiply by 2, kind of the opposite of what we think. And there we go, we have a horizontal compression, and here by a factor of 1/2. All right, so let's get rid of that. Go back to the original parent function there. There's our original parent function. What if we want to do a reflection? Well, that's simple enough. If we want to reflect it over the x-axis, we need to make the whole logarithm become negative. So if we do the negative log of x, you can see that we reflect it over the x-axis. And if we want to do a reflection over the y-axis, there's back to our parent function. If we want to do a reflection over the y-axis, we come up into the of, and we put the negative in there, and it's done a reflection over the y-axis. Your book has, again, a helpful kind of table for you to remember. It's on page 538, and this is it right here. This discusses all the things that we did in this video. And if you want to kind of make notes of that, write that down in your notebook. That might be helpful to you. But before we close, let's go ahead and do a couple questions. Here's one. And here's another one. And the last one. And that's it for today. We'll see you in class, and we'll try to do some problem solving involved with this stuff.